Today I will be presenting you about antimicrobial activities of T-derived flavonoids against skin Staphylococcus. I've been doing this research for the past 3 years, so there's a lot of information, and today I will briefly go over a part of the research. And my thesis advisor is Dr. Yorda. So what is tea? Tea is one of the most consumed beverages in the world. For instance, there's green tea, black tea, English breakfast, or chai. And surprisingly, they are all come from a plant called Camellia sinensis. Camellia sinensis is a tea plant originated from southern China, India, and Vietnam. But nowadays, it grows everywhere, even in Portland. So how one plant produces different types of tea? It is due to a different processing method. For instance, black tea here goes through the full oxidation step, whereas green tea and white tea rarely goes through any oxidation step. So polyphenolic compounds, also known as flavonoids, are abundant in plant and plant-based food. For instance, flavanone right there is found in parsleys, and the cytidine found in blueberries, and flavin-3, also known as epicatechin, is abundant in tea plants. So there are 4 major polyphenols, also known as catechins, in tea. The epicatechin we just saw is the simplest form of catechin found in tea. When epicatechin has additional gallic acid, it becomes epicatechin gallate. When epicatechin has additional hydroxyl group, it becomes epigallocatechin. And when epicatechin has additional gallic acid and hydroxyl group, it becomes epigallocatechin gallate. EGCG is the most abundant catechins found in tea. So why are we studying tea? From the ancient, especially in East Asia, tea served medicinal purposes. And nowadays, a lot of researches have been done in tea. For instance, cancer prevention, cardiovascular health, and antimicrobial properties. In this thesis, I focused on antimicrobial properties of tea. These are the hypotheses in my 41 pages of thesis. And today I will briefly go over the last one. EGCG, the most abundant polyphenols found in tea, possesses the highest anti-staphylococcal activities. So prior to our experiments, we isolated 2 most abundant bacteria found on your skin, Staph aureus and Staph epidermidis. And we identified it morphologically under microscope using gram staining, and biochemically using mannitol salt agar. It differentiates whether it is aureus or epidermidis. So before we test our individual catechins, we wanted to see the antibacterial effects of commonly used antibiotics. In this experiment, we used ampicillin, chloramphenicol, tetracycline in 5 different concentrations, and PBS as our control. We used a Kirby-Bauer test. How this method works is we first plate the bacteria on agar, then we take a disc of filter paper, dipped it into antibiotics that we want to test, and we place on the plate. From the highest concentration to lowest concentration, the zone of inhibition, this area gets smaller, suggesting that higher concentration, it suppresses the growth of bacteria more than the lowest concentration. Now we know that the Kirby-Bauer test worked. We conducted the same analysis, tested our individual catechins. We used 25 millimolar concentration of gallic acid, epicatechin, and EGCG and EGCG, and PBS as control against Staph aureus, and Staph aureus isolated from an individual with eczema, and Staph epidermidis and Bacillus cereus. The reason why there is different Staph aureus isolated, because from clinical literature, they demonstrated that individuals with eczema has higher population of Staph aureus colonization on their skin in comparison to epidermidis. So the result is pretty simple. From gallic acid and epicatechin, in addition to our PBS control, we weren't able to observe any zone of inhibitions. But from EGC, ECG, and EGCG, we were able to demonstrate a zone of inhibitions. And from the data we obtained from the experiment, we statistically analyzed it. There are two important things from this graph to take away. From ECG, indeed has the highest anti-staphylococcal activity against Staph aureus and epidermidis, whereas EGCG shows the highest activity against Bacillus cereus. So previous experiments have demonstrated that EGCG, or catechins in general, possesses relatively high anti-staphylococcal activities. And to demonstrate whether EGCG acts as bactericidal or static, meaning does EGCG kill the bacteria or does it suppress the growth of it, growth dilution susceptibility test was used. How this test works is we take a equal amount of tryptic soy broth, plated either aureus and epidermidis, then we serially diluted EGCG from 0 concentration to 1,000 micromolar concentration. As you can see, the cloudiness changes, which means there's a lot of growth on this side, and the growth of bacteria is either suppressed or dead. And we took the samples from here, we plated on the tryptic soy agar, and we found that there is still growth on this tube compared to this, suggesting that EGCG is not bactericidal, but it is bacteriostatic. It suppresses the growth, but it doesn't kill all the bacteria. So to investigate possible cause of that previous experiment, we performed gram staining. So we observed a relative decrease in the intensity of staining from the deep purple to pink, and clumps of damaged or lysed cell were observed, which suggesting that bacteria cell may be the possible target of catechins. This is the overall conclusion of the thesis, and the part that I explained to you today, it is well through this one and this one. So ECG possesses the highest anti-staphylococcal activity than EGCG, and effect of catechins against staphylococci is made due to cellular disruption. Acknowledgement. I would like to thank Dr. Yorno for unconditional support, guidance, and patience. This is from my freshman year to senior year. I've been working with him for 3-4 years, so thank you for putting up with me. And my thesis committee members, Dr. Wise and Dr. Coltman, and Dr. Johnson for a support, and my lab partner Josh for contribution, family and friends, and Suri and Math and Science Department for the opportunity and funding. Questions? Question for me? Yes.
So you mentioned cell wall disruption as the mechanism. Do you have any more information? Have you looked into what exactly? Is that just morphological based on morphology, or?
Cell wall disruption, yes, but I did further digging.
You have not?
I did. Some said it interacts with the cytoplasmic membrane. So from the gram-positive, the peptidoglycan, the wall, apparently the catechin affects that layers, and it disrupts that bonding.
Okay.
Or there's another theory saying it interacts with DNA gyrase. That's why they're dilute or suppressed. But further research definitely needed to confirm whether it is cellular disruption, cytoplasmic membrane, or DNA gyrase. It's not confirmed, but those are the theories. Hmm? Yes.
So there's a lot of people here that weren't at your thesis defense.
Mm-hmm.
So this is related to skin bacteria NT.
Yes.
But I'm drinking it.
Yes. You are.
Okay. Do you want to comment about, should I pour it on me instead?
I mean, you can. But definitely it affects our gut bacteria and oral bacteria when you drink it. But the reason why the research was focused on skin bacteria is that some culture in Asia, they bath the babies with teas, or my mom used to say, wash your face with green tea, it's good for you. So I never understood why, and she's chemist. Yes, 8 o'clock. Okay. So I did this and found some remarkable things.